Everyone, welcome to lecture 4. So in this lecture I'll be discussing about number system. Let me briefly tell you why do we need it. Uh, as you have seen that we are doing a lot of operation on computer. Uh, like we we perform addition, we perform various operation like addition, multiplication and everything. So in this regard we need to represent numbers in a computer. How do we do that? Right. So there should be some way of representing numbers in a computer. Not only numbers, we also need alphanumeric character, right? We enter names and everything. How do those uh, information or data are stored in computer? So we must have a system in place using which the numbers are actually stored in computer. Okay. So for that reason, let us look into various number systems that are available and that are used in today's context. So basically, we'll be discussing about binary, hexadecimal, octal, and decimal. Very briefly, I've discussed about decimal in the last lecture. Uh, we are familiar with this, right? Which is basically consists of digit from 0 to 9, and every digit position has a weight which is power of 10. Now the base of the radix is 10 here. I already took this example. So anything before the decimal point, we will start from 0. So the base will be 10. To the power it will start from 0, 1, 2 and so on. So there are three numbers here, 0, 2, 5, 0. So 0 will be into 10 to the power 0, 5 into 10 to the power 1 and 2 into 10 to the power 2. But after the decimal point, this is the fractional part, this will start from uh, it will start from 1 basically. So we'll multiply 6 into 10 to the power minus 1, or we'll divide 6 divided by 10, that is 10 to the power minus 1, and 7 divided by 100, which is 7 into 10 to the power minus 2. And this is how we go on, and we get the these numbers are actually we can convert this number. This is how the decimal representation takes place. Now let's move on to the binary system, because I already discussed with you that everything is binary. So uh, everything boils down to transistors, which is an on-off switch, and we need to represent everything in terms of 0 and 1. Even if it is decimal number, we need to have a mechanism through which the decimal number should be converted into binary number, and that number will be stored. We'll see various ways of number storage, the various ways which are there. Let us see binary number system. Binary number system, the base is 2. There are two numbers, only 0 and 1. And every digit position has a weight which is power of 2. Decimal system, the power was 10. Here the power is 2. So how do you represent 110? So 110 is a number which is represented by, again, 0 into 2 to the power 0. Here the radix is 2. So and we start from here 0, 1 and 2 and so on. So 0 will be multiplied with 2 to the power 0. 1 will be multiplied by 2 to the power 1 and so on. And this is how we represent it. Similarly for the fractional part, if you see, 0 will be divided by 2 to the power 1, uh, 1 by 2 basically, and plus 0 into 1 by 2 and 1 multiplied by 1 by 4, which is 2 to the power minus 2. This is how we represent the numbers in binary system. Now let us look into conversion. So in this lecture basically we'll be taking a lot of examples and see how this conversion takes place, and how do we convert from binary to decimal or from decimal to binary and so on. In this lecture specifically, I'll give you a broad details of how we can do that. Basically the steps that are required to perform the operation. But for performing the operation, we will take the examples in the in-class lecture. Okay. Let's see how can we convert binary to decimal. How do we convert a binary number to a decimal number? So for a binary number, let's say any number 110, let's say. Each digit position of a binary number has a weight, some power of 2. And if you see how a binary number is represented, it is represented as b will be equals to bn minus 1, bn minus 2 up to b0. Fractional part will be starting from b minus 1, b minus 2, and so on and so forth until the last number. Okay. So how we can convert this binary number to a decimal number? So for converting this binary number to a decimal number, all we need to do is we look into this formula, okay, and we replace it with this. What we are doing here, we are starting from I, which is minus m, to n minus 1. If your total n is 5, it will be n minus 1. So it will be 4. What we have to do, we have to multiply this particular digit, which is bi, into 2 to the power I. Okay. Here I is minus m, so you have to multiply with bi multiplied by 2 to the power minus value, whatever is there, until minus 1. And similarly for the part before the fraction, we have to just take those values and multiply it with just 2 to the power I. This is how we will take a lot of examples in class lecture, which will make your understanding much more easier. And I'm pretty sure that many of you might already know about it. That's very good. You can just take up many problems to solve. Now, how do we convert decimal to binary? So what we have done for converting binary to decimal, we have multiplied with 2 to the power. We have multiplied with 2 to the power 0, 1, 2, or for the fractional part 2 to the power minus 1, minus 2, minus 3, and so on and so forth. So here, for decimal to binary conversion, here also we have two parts, integer part and the fractional part. And what we do, let's see. For the integer part, what we do, we divide it repeatedly by 2. Okay, and we accumulate the remainder. In some case the remainder will be 1, in some case the remainder will be 0, and this is how we see how it will go. And finally we write the result in reverse order. Okay, that is how we get the value. Okay, this is a very simple step. The integer part, we divide by 2, we repeatedly divide by 2 and see what is the remainder. We write it down, and then finally the answer that we have to write, we write it in reverse order. Now for the fractional part, what we do, we repeatedly multiply the given fraction by 2 and accumulate the integer part, uh, 0 or 1. Whatever integer part is coming, either it is 0 or 1, we accumulate it. If the integer part is 1, we chop it off. Now it is done basically. But sometime you see this goes on repeating and you are not getting the integer part as 1, then it will just repeat on. Sometime it is 0.3333, it goes on. So we just take it to few decimal places, the answer. Okay, this is how we go. And arrange the integer part in the same order as they are obtained. So for writing the whole thing, the integer part will be written in reverse order, multiplied, we write, and the fractional part after the dot will be taken as per the fractional part. We have to multiply it and then we have to get the value. This is how decimal to binary conversion takes place. Let's move on. Now, binary decimal system is perfectly all right. But you see, for writing anything, if you use binary number system, the string become huge, right? 0101. So representing anything becomes cumbersome. So for human understanding and also for writing codes easier, and for many other purposes, we use hexadecimal number. But do not confuse that. Ultimately, the computer can only understand binary numbers. But this is a way of representation for our own ease. The hexadecimal number has been used by many systems. Okay, this is nothing but a compact way of representing the same binary numbers. Starting from 0, it is just represented with 4 digit, and we have 16 different symbols, and here the radix is 16. How many digits we are having? 0 to 9, and then we have A, B, C, D, E, and F, 6. So 0 to 9, 10 plus 6, A to F is 6. And this is how it is represented. 0 to 9 is straightforward, but we are representing everything in terms of for using 4 digit we can represent it. And starting from A, it is basically 10, 11, 12, 13, 14, and 15, which we represent as A, B, C, D, E, and F. Okay, so all these 4 digit numbers here are represented in terms of just a single digit. Okay, that is why after 9 we are representing 10 as A, 11 as B, 12 as C, 13 as D, 14 as E, and 15 as F, and we go on. How do we convert binary to hexadecimal? Basically, it's very straightforward. uh, we have a string of zeros and one. We need to convert that to hexadecimal. All we need to do is, like, we scan the number from right to left, okay, and we group it into 4 bits. Finally, if the last set of 4 bits is not coming, let's say 1 bit is coming, only 1 is left or 0 is left, we add leading zeros, okay, and then we make it a 4 bit number, and then we just convert it to, like, we already know what is what, those 4 digit numbers. So we have all possible 4 digit numbers, and we just replace with it either 0 or 0 to 9 or A to F, any number. And for the fractional part, we just scan it from left to right basically, and we translate each group of 4 bits into corresponding hexadecimal number. So we'll take a lot of examples which will make things clear for you. Next, hexadecimal to binary conversion. This is very straightforward. uh, if you have to convert this 3A and 5, which is represented in hexadecimal number, you just convert this 3 to, what is 3? 3 is basically 1 1, and as we have to represent it using hexadecimal, we'll add 0 to make it 4 digit. So 0011. A is 1010. 5 is 0101, and this is what is represented in binary. That's it. So what will be 1.8 then? 1.8, 1 is 0001, and 8 will be 1000, and that is how we convert it. So we see that these conversions are very straightforward. Let's move on to the next system, which is octal number system. Octal number system is another compact way of representing binary number, just like hexadecimal number. It is the radix here is 8, and we can represent numbers from 0 to 7. Okay, this is how it is represented: 0, 1, 2, 3, 4, 5, 6, and 7. Okay, now similar way we can convert a number from binary to octal. How do we do this? Same way, we scan the numbers from right to left. The same way we did it for hexadecimal number, we have to do it for binary numbers. And we scan the numbers from left to right. We translate each group of 3 bits into corresponding octal number. We know octal number is from 0 to 7. So we just have to convert that, and we add leading 0 whenever it is necessary. For the fractional part, we have to scan from left to right and translate each group of 3 bits into corresponding octal digit. So these are basically straightforward way of converting numbers from one number system to another number system. Again, I will repeat this every time. In computer, everything is binary. But for our own convenience and for many other purpose, we need different number system. And so we are discussing here about hexadecimal number system, octal number system, decimal number system, and so on and so forth. Okay? So this is how the conversion takes place. Now, how do we convert an octal to binary? This is very straightforward and very similar to what we already discussed earlier. For hexadecimal number, if it is 325, we here it's not 4 bits but 3 bits. So we convert 3 into 011, 2 into 010, and 5 into 101. This is how we represent. Similarly, for 1.25, 1 is 001, 2 is 010, and 5 is 101. This is how we convert and we perform it. So now in this lecture, what we have seen that we have seen basically three number system: decimal number system, no, four: decimal number system, binary number system, hexadecimal number system, and octal number system. And we have seen that how do we convert one form to another. Now look, I have shown you how to convert from octal to binary, but you can also convert from octal to hexadecimal or hexadecimal to any other number system, right? So there are ways to do it, and you can obviously do it by converting from one form to another and then from that form to the next form. So this is how you need to do it. Next, I'll be discussing about uh, number representation. How do we represent the number? Okay, so we'll move on in the next lecture where we'll discuss about number representation in greater details. Thank you.